Good morning, students. This is standard hydrogen electrode. In short form, it is called ch3. And this is about the construction of standard hydrogen electrode. Here, to construct the standard hydrogen electrode, one platinum wire is used, and the platinum wire is sealed in a glass tube. This is glass tube. The wire is sealed in a glass tube, and the platinum wire is attached to a platinum foil, and the platinum foil is coated with platinum black, and this platinum wire acts as electrode, and this platinum electrode is dipped into a solution which is exactly 1 molar concentration HCl solution, and from this side pure hydrogen gas is supplied at 1 atmosphere pressure. Now here we are using some standard condition like the concentration of the solution is 1 molar, pressure of the gas we have supplied, that is exactly 1 atmosphere, temperature is 298 Kelvin. So that standard conditions are maintained, and that is why it is called standard hydrogen electrode. So this is about the construction. Now after constructing this, when hydrogen gas is supplied at 1 atmosphere pressure, that hydrogen gas, when it goes into the solution, hydrogen will convert it to H plus ion by loss of 2 electron. Oxidation takes place here. When hydrogen gas is supplied, when it goes into the solution, the hydrogen gas is converted to hydrogen ion by loss of 2 electron. Oxidation takes place. Similarly, this is the solution of HCl. The solution contains some H plus ion and Cl minus ion. This H plus ion, which is coming from HCl solution, the H plus ion will gain that 2 electron, and it will form hydrogen gas also, and that hydrogen gas bubbles. You can see I have shown some bubbles. These are the bubbles of hydrogen gas which is coming from this hydrogen ion. Here reduction takes place. Inside the electrode both oxidation and reduction takes place. That means this electrode can act as anode also, it can act as cathode also. If ch3, standard hydrogen electrode, act as anode, then the oxidation reaction is this one, and if ch3 act as cathode, then the reduction reaction is like this. It can undergo both oxidation and reduction, and under this condition the potential of hydrogen electrode is found to be 0.004. So one of the characteristics property of standard hydrogen electrode is it can act as cathode also, it can act as anode also. It can undergo both oxidation and reduction. When it acts as anode, loss of electron takes place, it undergo oxidation, and when it acts as cathode, it will show reduction. And under this condition, the standard potential of hydrogen electrode is found to be 0.004. So that is why if sh3 is given, if hydrogen electrode is given, the potential always you have to consider it as 0.004. So this is about the standard hydrogen electrode. Now, what is the use of this standard hydrogen electrode? Yesterday, as I have told you, suppose a zinc sulfate solution, a zinc rod is dipped in zinc sulfate solution, and a copper rod is dipped in copper sulfate solution. Yesterday you have constructed the electrochemical cell. These two electrode you attach with some ammeter like this, and the solvents you have to use. Now, as I have told you, instead of ammeter, if you use voltmeter, then what you will get? You will get the potential difference between these two electrodes. Now, under normal condition, standard potential value you will get in table. In normal condition, when you construct the electrochemical cell, what is the individual potential of this zinc electrode? what is the individual potential of this copper electrode. To find out that, what you can do, you remove this copper electrode and here you apply one SHC, I mean standard hydrogen electrode. Then the standard hydrogen electrode will act as cathode. So then you can see the potential difference here, and that potential difference will coming from the zinc electrode. I mean you can find out the potential of zinc. So this is one of the use of standard hydrogen electrode. Similarly, if you want to know about the copper electrode potential, then SHC you place this side, you can find out the potential of copper electrode also in the voltmeter, because SHC potential is always 0. So the difference will coming from only one electrode. So like this way, if you want to find out the potential of some individual electrode, by using SHC, by using standard hydrogen electrode, you can find out the potential. So this is one of the application of SHC. So by using SHC, you can find out the individual potential of different electrode. And one of the characteristics property of SHC is the standard hydrogen electrode, you can act as cathode also. The standard hydrogen electrode, you can act as anode also. And the potential of standard hydrogen electrode is always 0.00 volt. So this is about the standard hydrogen electrode. Okay, this is one of the question. Write the half cell reaction and the overall cell reaction. For the cell, this one cell is given, the cell representation is given. Calculate the standard EMF of the cell. Given standard potential of silver is 0.80 volt and standard potential of zinc is minus 0.76 volt. So how to write the half cell reaction? To write this, we have to do like this way. Oxidation half reaction is zinc is converted to Zn2 plus aqueous by loss of 2 electron. This reaction is called oxidation half reaction. Reduction half reaction is silver ion is converted to silver by gain of 1 electron. Now when you write the overall equation, this is your overall equation, overall reaction. When you do the overall reaction, the electron must be cancelled. Here 2 electron, here 1 electron, it will not be cancelled. That's why you have to multiply this equation by 2, so that 2 electron will be cancelled. Electron must be cancelled in overall reaction. Then the equation becomes Zn solid plus twice Ag plus aqueous. This is aqueous. It gives Zn2 plus aqueous plus silver solid. So this is called oxidation half reaction, this is called reduction half reaction. When you combine both, then you will get the overall reaction. Reactant you write in reactant side, product you write in product side, and this is about the overall reaction twice Ag. Now this is about the half cell reaction, overall cell reaction. Now you have to calculate standard EMF. As you know, E naught cell is equal E naught of cathode. Here cathode is silver, right side is always cathode. E naught of silver minus E naught of zinc. Left side is always anode, cathode minus anode. So silver value is given 0.80 volt minus zinc value is given minus 0.76 volt. Minus minus become plus, then you will get 1.56 volt. So this is about the standard EMF for this cell. So like this way, you have to balance the equation. You can find out overall reaction and you can find out the EMF of the cell. Thank you.